Hello and welcome back for part 3 in this guest lecture in the course Recent Developments in Advanced Innovation Economics. My name is still Johannes Dahlke and you're still listening to a talk about AI meeting responsible research and innovation. Now, if you recall, in part 2, we were talking about a definition of responsible research and innovation, and we were able to derive a distinction between looking at the marketable products or processes, which are the outcome, the result of an innovation process, and the innovation process itself, in order to somehow assess its social desirability. Now, up until now, in this talk, we've kind of taken on the former perspective and treated AI as a product of sorts, quickly and surely diffusing into our society and carrying with it societal implications. What I would like to do in this final third part in this guest lecture series, I would like to take up the latter perspective and look at the role of AI as a tool transforming the innovation process itself. And I feel like this perspective is crucial in understanding the transformative power that AI has for our society, not only in the short term, but also long term. The way I would like to start this is by looking at some theory and then afterwards quickly showing you some cool examples, all right? So going way back to Joseph Alois Schumpeter and then many great scholars following him up, the field of evolutionary economics was created and developed, which I'm sure you must have heard about in previous lectures in this course. So I'm sure you're well aware that in evolutionary economics, technological innovation is seen as the main driver behind industrial development and productivity growth within our economy. Now, taking this as a baseline, in the new millennium, we saw a lot of studies coming up examining the effects of information communication technologies on the company level and also on the sectoral or national level. Now, as scholars interested in AI, we often have to refer back to studies focusing on ICT because we simply don't have much data on the adoption of AI yet. So either there are simply not enough companies using AI already. So my personal guess would be that approximately 5 to 8% of companies use AI. And if they use AI, they may not be willing to share this confidential information with researchers publishing the research, right? So we have to compare, sometimes we're able to compare AI to ICT in a broad sense being kind of similar, right? Also relying on the rise of data, the rise of the internet, the increase in computational resources, somehow maybe encompassing AI or being somewhat similar. Now, for ICT studies, we see that the adoption of ICT positively impacts firm productivity and firm performance. And not only that, but also that ICT adoption may lead to higher innovation performance. So companies being able to come up with more or more successful new or significantly improved products or services. And literature argues that this may be due to companies gaining in productivity, so becoming more efficient with the labor or the capital they own, or they become more flexible in their company processes. And through adopting ICT, they also may be able to create higher quality of products and services. Now, recently, for example, Cockburn, Henderson, and Stern have argued that AI might go beyond these effects we see for ICT. So not simply making processes faster, increasing development speed, maybe freeing up resources that can be invested in R&D ventures, but that AI may more radically transform the activities or substitute some activities within the innovation process, as it is a general purpose technology that can be applied for many different tasks, many different fields and sectors, right? And that AI, in fact, be somewhat of a new method of invention that has the potential of carrying much larger impact than simply developing a new product or implementing a new process to become more efficient. So I would like to focus just on this notion of AI transforming the innovation process. And the way I would like to do it is we're going to start off on the micro level and look at an innovation process that could take place within a typical firm and see where AI might come in here. And then after that, we're going to take a step back and see how AI may influence more on a meso level the innovation system as a whole. Okay. So we're starting off small, and in order to understand the impact of AI on innovation activities on the firm level, we need to have an understanding of how a typical innovation process looks like. So in innovation studies, we have long moved past a linear understanding of the innovation process and have developed more complex and interlinked models of the innovation process. As you can see here, the chain-linked model as introduced by Klein and Rosenberg, and you can see typical stages and activities within innovation management, and all of them being interlinked with feedback loops going back and forth, and this whole process being implemented in larger society. So having a research community producing fundamental basic research and findings, and these findings slowly diffusing into the knowledge base of a society, therefore also affecting the activities within the innovation process. Now, these complex models may be more accurately depicting reality. However, for the sake of simplicity in this talk and for the sake of clustering the applications of AI in this process, I would like to take a step back and look at a more linear, basic understanding of the innovation process and show you a simplified innovation funnel as introduced by Clark and Wheelwright in 1993. What you can see here are two white thick lines at the top and at the bottom, and these lines represent the boundaries of the firm. So within the boundaries of the firm, you see all these white bubbles representing new ideas or innovation projects within the company. And these projects go through three phases: the ideation phase, where there are a lot of different sizes and shapes of ideas, and they get slowly filtered down in the design and development phase, and then only very few ideas and projects make it to actual market introduction in the end. Now, what I would like to do is go into detail for each phase, what's happening in each phase within a company, and then show you where AI might come in, okay? Starting off with AI for ideation. So what's happening in this phase is one of two things. First, companies screen the market and see what do customers need, what do they want, where is the potential to create a new market. This will be the market pull argument, so the market pulling for an innovation. And then on the other hand, a company might also screen the technological horizon and see what kind of promising technologies are coming up that may be implemented in the new product or service to be offered to the customers. This would be the technology push argument. Now, at the end of this phase, there is a business case created, and all the projects that don't meet or that are not in line with the competences or the resources of a company are filtered out. Okay. So for this phase, we actually see that AI is most heavily used in this front end of the innovation process in practice already. And the use of AI centers around the idea of open innovation, as described by Chesbrough in 2004. And this theory says that, or acknowledges that, not all the smart people and most creative people in the world work for your company. There are other valuable ideas outside the boundaries of the company, external knowledge that you as a company may find valuable in creating new products or services, or might find worth pursuing. This is the reason why we see, for example, big incumbent companies invest into venture capital funding in order to extract knowledge from a new, small, innovative startup and take this knowledge, bring it inside the boundaries of the firm, and use this technological knowledge or these ideas a startup might have to develop new products or processes on their own. Okay. However, other companies or startups are not the only external source of knowledge. So as I said, in this phase, we mainly see a market orientation. So a problem exploration where we need to explore what kind of problems are there with customers and select a problem that we would like to address. So for this activity, we see AI mainly being used in the form of text mining, for example, in online communities or on social media, where we can automatically assess vast amounts of text data that describe what kind of problems customers are facing that are already using your products or not using your products but are situated in a similar or in the same market. Okay, so we see some studies here by Christensen and co-authors, and they examine, for example, the Lego community, where very avid Lego fanboys are coming up with new product ideas in online forums, right? Or they also examine the beer brewing community, where there are a lot of ideas for new processes to brew beer that are coming up in this online community and may be leveraged by a company that would manually not be able to handle all of this text data on their own, but an algorithm can identify the most interesting or the most frequent ideas that customers or consumers in a certain market are coming up with. Now, the other activity is once you've identified a problem you'd like to address, you need to find a solution, a technical solution, how you want to address this problem. And this is the activity of solution exploration and selection. And here, AI might as well come into play in the form of text mining, but not being applied to online communities, but to patent databases, for example, or crowdsourcing platforms, or online innovation contests where companies set and introduce a technical problem and then ask individual developers or startups to come up with solutions to this problem. One of my favorite examples here comes from American football, where researchers try to reduce concussions when players run into each other and suffer a concussion. And the way they were able to do it is by analogy mining, using an algorithm to find semantic synonyms to the term reduce concussion, for example, repel energy. And this algorithm is then let loose on a patent database and sees what kind of technical solutions fit to this semantical phrasing of the problem repel energy, reduce concussion. Therefore, not only going beyond the boundaries of the firm, but even going beyond the boundaries of the industry, looking at all different kinds of patterns and solutions to problems that are semantically very similar, but come from a completely different field. And through this process, the researchers were able to identify that a new helmet could be developed that is magnetically charged, right? Magnetically charged with the same positive loading, and these helmets would then deflect off each other just before hitting each other and creating a concussion of the player. So this is an example where AI might transcend the boundaries of the firm and come up and either identify problems of customers that need to be addressed, or also for the issue of how to address these problems from a technical perspective. And this develops nicely into the second phase, which is the design and development phase. So in this phase, a company sets technical goals, designs first prototypes, designs technically alternative solutions for different products, and test this solution. Okay, and I would like to illustrate why AI is valuable here by showing you this thought experiment that you can see in the middle here. It's called the Dunker's candle problem. And in this problem, you have the task, so feel free to think along here, to fix and light the candle to the wall you see on the left, which is a cardboard wall. And the materials you have are quite limited. So you have the candle, you have a stripe of matches, and you have a box of text that you can see there. Now, feel free to pause the video and try to think of some solution how to fix the candle and light the candle, fix the candle to the wall and light the candle. Now, to be honest, when I was first introduced to this problem, I didn't come up with the right solution either. So many people think about, okay, maybe we can use the tags to somehow pin the candle to the cardboard wall, or we can light the candle and use the candle wax to stick it to the wall. However, none of these solutions really work, and the right solution, or they may work, but the better solution would be to simply use the tag box as a platform that you can attach to the cardboard wall using the tags, and then put the candle into the tag box. And the reason why, statistically speaking, you shouldn't have come up with this solution is a problem, a cognitive limitation that we call functional fixedness, okay? And this basically states that neurological tactics in analyzing common objects lead to screening out the awareness of features that are not important for direct use. So in the case of the candle problem, you simply see the box of tags as a box that carries tags, and not as a kind of box or platform that can also support other structures, such as the candle. Or to put it differently, to a man with a hammer, everything looks like a nail, right? So this is a cognitive limitation called functional fixedness. Then we have a limitation called goal fixedness. So if your supervisor comes to you, being an engineer in an R&D department, then it's already crucial how he phrases and narrows down a problem. The way he phrases an assignment may already influence how you think about solving this assignment. And then lastly, we have a design fixation. So when developing a new product or asking to create a new design for a product, people tend to fixate on the features of the current design, right? So if you think about an iPhone, every year there's a new, or every other year there's a new iPhone introduced, and it looks very similar in design to the previous version. Now, this might also be the case because it's simply, the company simply wants to innovate incrementally, never change a running system. It sells, so why change a lot, right? But this is a problem that we humans have, that we tend to fixate on the design that is already there. And an example of AI being helpful here is what you can see in the background image. There you can see a rocket engine, right? That was developed and designed by AI, by a startup called Hypergenic Technologies. And the way they did it is they simply fixed a number of really crucial parameters that every rocket basically needs to adhere to, or is really crucial to the functioning of a rocket, and then let the AI design a form for the rocket engine completely on its own. And then later on, they printed it out with a 3D printer. So complementarities between technologies here, right? So setting only the most crucial parameters and then letting the AI design and refine a new shape for this rocket engine. So lastly, we have AI for diffusion. And in this implementation and market diffusion phase, we see companies setting up early manufacturing lines and also starting with marketing activities to educate the customer on the new product that will be launched, right? So we may see AI coming in for the optimization of early production lines, so with maintenance prediction and failure prediction, but also for marketing activities. So I have the example of Marketable here, which is a startup using AI and again, natural language processing, so text mining, in order to identify the most relevant new customers for your new product. So by looking at social media, the company is able to identify and target customers that have a problem that your new product or service may address, okay? And then there's another role of AI that has more to do with design thinking. So it goes back to the design phase a little bit, but a design phase that is delayed into the phase of market introduction. So basically in design thinking, you have a very iterative process where you have a prototype, a minimum viable prototype, and then you give it to a customer and he experiments, an early adopter experiments with this product. or you have a laboratory experiment, and then you see what works, what doesn't work, and you refine the product. What AI offers is the opportunity to take this iterative process and implement it with the customer itself. So gathering live data from the usage of a product by a customer, and the AI being able to refine the product while already being in the hand of the customer to the needs of this specific customer. So one example we already see for such products are Amazon Alexa, speech recognition, right? The algorithm learns and adjusts to the way you speak and gets better with every command or conversation you have with the system, right? This is a product that starts out being maybe suboptimal, but then adjusts and gets better, increases its performance, and makes incremental adjustments to fit neatly to individual customer needs. And we may even think about other applications using just this iterative design process that gets started when the product is already in the hands of the customer by leveraging data analytics. Okay, so iterative innovation loops are another application for AI in this process. So after looking at all of these examples of the influence of AI within a firm level innovation process, I would like to get back to the question that is really of interest to us in this talk. And that is, does AI help the innovation process to be more responsible? And in order to answer this question, I would like to go back to the notion of responsible research and innovation and look at the 4 dimensions that are characterizing activities and the state of responsible research and innovation. So for each of these 4 dimensions, I will provide you with some positive and some negative impacts as I see AI impacting these dimensions, and then leave you to judge for yourself how these arguments weigh against each other. So we start off with anticipation. And here, actors in the innovation system basically consider what is known about their innovation. So what is likely to happen when this innovation is diffused, handed to our customers, and diffused in society? What is plausible and what is possible? And here, the predictive capabilities of AI surely may help us in forecasting and predicting, for example, customer satisfaction or other effects in society caused by a diffusion of an innovation, right? On the other hand, we may be able to forecast something, but we're not really sure of the driving factors behind it because, in the case of a neural network, the traceability back to the input factors is really, really hard to gain insight into, okay? The next dimension is reflexivity. So this means, as an innovator, reflecting the own activities and being aware of the limits of knowledge. And maybe also second order reflexivity, meaning being aware of the cultural influences, or for example, the influences of a company culture on the innovation behavior. And here, AI systems may help us in reducing either cognitive biases, as we just saw when talking about the design phase in an innovation process and the problem solving phase. So an AI system suggesting new alternatives to us, therefore letting us realize our own cognitive limits. And on the other hand, the statistical analysis tool that AI provides us with may help us in detecting biases in data, for example, caused by systemic discrimination. So we may be more aware of these biases in the data that we work with in order to innovate, right? On the other hand, again, we don't really know how an AI system works within its black box if we're looking at neural networks. So by substituting some of the activities to AI systems, we lose reflexivity because we don't know how the system is actually coming up with its solutions. The next dimension is inclusion. And this basically means including new voices in the governance of science and innovation beyond engagement with stakeholders. Basically meaning listening to the voices of all societal groups affected by an innovation. And here, AI may come in positively by letting us analyze the reactions and thoughts and needs of large communities based on big data, right? Community mining, using text mining to get a feeling for, using sensitivity analysis or sentiment analysis to identify whether customers or another societal group are reacting positively or negatively to an innovation, and what kind of needs and concerns there are. On the other hand, using AI systems in the innovation process might cause a problem of misrepresentation, like we heard in the first part of this talk. If we have a data bias, or we have a problem of proxy discrimination in our data, we might be misrepresenting some of our customer segments, or developing innovations that are purely focused on a homogeneous customer group, not representing the heterogeneity we have in our society or in our customer base, therefore excluding the concerns of some people. So if we're not aware of these biases in the data that the algorithm works with, we lose or we lack this inclusion. And then lastly, we can look at responsiveness. And this means the capacity to change or shape direction of the innovation process in response to stakeholder and public values and changing circumstances. So changing societal environments, right? And here AI may come in positively, as it allows us to incrementally adapt and update the innovations as they're already diffusing into society and are in the hands of the customer and can react to individual customer needs. On the other hand, we may have a problem that is the loss of control, right? If we heavily rely on an AI system to identify these changing circumstances in society and react to them, we can never be sure whether the AI system actually adequately addresses these changing environments and how it does it. And we cannot manually adjust to these changes because we don't really know how a neural network that is in the center of this innovation process works and how it weighs the input factors. So we might lose the capacity to be responsive to changing circumstances. So this was looking at AI on the innovation process and the influence of AI on the micro level, the firm level. And I promised you to take a step back and have a look at the influence of AI on innovation systems. And now first, let's take a brief look again at the definition of technological innovation systems that are defined as networks of agents interacting in the economic industrial area under a particular institutional infrastructure and involved in the generation, diffusion, and utilization of a technology. And first, I would like to start out by looking at the technological innovation system around AI. Yeah? And as you probably are well aware of, due to previous lectures in this course, an innovation system has some structural components, so actors like governments, companies, civil societies, NGOs. Then we have some institutions such as hard law, or soft institutions such as traditions, common habits in society. And we have interconnections of actors resulting in networks within an industry, for example, or also simply personal contacts. And these structural components basically produce a set of functions that drive the dynamics within an innovation system. And for that, I would like to show you the next picture, because here we see what kind of functions are at the center of an innovation system and create a certain dynamic, which we may call virtuous cycles. So these virtual cycles are basically activities of the actors in an innovation system reinforcing themselves and therefore enabling the pervasive diffusion of a technology. So one very common dynamic of such a virtuous cycle is starting with entrepreneurial activities, and they lobby for a market formation. So they try to convince companies that this technology and their new offering is worth buying into. And once this market has formed, of course, there are new incentives for other entrepreneurs to enter the market as well, and then thereby lobbying again. So we have a reinforcing cycle here. The second motor starts with entrepreneurial activities, and they lobby for allocation of resources, more resources to do R&D through government funding, but also through attracting venture capital, right? And this in turn leads to more knowledge creation, and in turn leads to more entrepreneurial activities. And we see both motors really kicking in right now for the AI technological innovation system. So we see companies like Google setting up sales department to sell their machine learning solutions to companies that are not able to develop them themselves. And the market is slowly forming. We also see more startups hitting the scene by democratizing AI and offering AI as a service to companies, right? On the other hand, we see a steep increase in venture capital funding and also more research funding by public institutions. And then we have the third motor here that starts again with entrepreneurial activities. And then we have that crucial function of guidance of search, basically meaning positive and negative signals by civil society, companies, or governments to drive the technology in a direction that is acceptable to society and desirable to society, and basically encouraging more entrepreneurial activities, but also more research efforts, leading to more knowledge creation that results in more knowledge creation. And this in turn leads to more entrepreneurial activities. And we see that as well for AI, as we see a lot of research funding, again, by public institutions, but also national AI strategies being issued here. So we see that the technological innovation system around AI is really kicking into gear, okay? But now the question is, we don't want to look at the technological innovation system of AI, but how AI influences other innovation systems. And for that, we have to remind ourselves that AI is a general purpose technology. So it enables the use of other technologies. It enhances innovation complementarities. It spreads through the economy while fostering productivity gains. It enables new inventions and innovations that would not be possible without the general purpose technology. It's pervasive and widespread, and it has no close substitutes. I think points 1 to 5 are very much true for AI, proving the point that this is a GPT. And point 6 we can argue over, okay? So on the right, you can see how different kind of innovation systems interact, okay? So in the middle, we see a technology-specific innovation system for a technology that is not a general purpose technology. For example, solar panels on a roof, okay? And we see that this technological specific innovation system is connected to different kind of other national innovation systems. So for example, the diffusion of solar panels may depend on national policies to encourage the spread of solar panels on houses. It may be linked to national housing markets, how many new houses are actually built where solar panels can be put on the roof, okay? And it also interacts with different kind of sectoral innovation systems. So for example, for a solar panel to be built, you need microchips, you need other technological components that stem from a different sector, right? So we see some interconnections here of a non-GPT, just a specific purpose technology, being connected to different kind of national innovation system and sectoral innovation system. Now, the picture looks a little bit different for a general purpose technology, which you can see on the right here, right? And here, let us define the technology specific innovation system in the middle as AI. And as you can see, AI basically is connected to all national innovation systems there are across the globe, and hitting and being linked to all kinds of sectoral innovation systems, as you can see. And this proves the point of AI being a technology that enhances the capabilities of other technologies. And this carries some major implication. So if the ultimate goal is to drive economic growth through technological change, then it might be an implication to policymakers to focus on fostering the positive and reinforcing dynamics within a technological innovation system for the general purpose technology, because by enhancing the technological process of the GPT, you simultaneously enhance the capabilities of all other technological innovation systems or sectoral innovation systems or national innovation systems. So if an innovation system does not function well for a given general purpose technology, it would negatively affect all the specific purpose technologies. Or if it functions well, it would positively affect all the other specific purpose, all the other innovation systems around a specific purpose technology. Okay, so this is the influence a general purpose technology may have. And as you can see, it's really pervasive and needs to be paid attention to by all parts of society. Okay. So to wrap this up, I would like to answer the question, is AI research and innovation responsible? So before we were looking at the question, does the influence of AI on the innovation process is positive or negative with regards to social responsibility? And now we take a look at the AI innovation system itself and ask the question whether this research in AI is actually socially responsible. And therefore we go back to the definition of von Schomburg of responsible research and innovation. And again, I would try to highlight some positive and some negative impacts here, okay? So we start by the statement of RRAI being a transparent, interactive process by which societal actors and innovators become mutually responsive to each other, okay? And here, as I show you all of the points I wanted to make right away, so for this part, we see movements like the Asilomar principles, the beneficial AI movement, right? Where different kind of researchers, companies are agreeing upon a common set of values that are important for the development of AI. So this is a positive development. We also see increased political awareness, increasing this guidance of search function we just talked about inside the innovation system around AI. On the other hand, we see some negative developments. For example, the increasing dominance of industry, also leading to a balkanization of research fields. So research fields actually separating from each other and not interacting more. In the beginning of AI, this was a very heterogeneous field, including sociology, psychology, neurology. All these different kind of research fields were coming together to create AI. Nowadays, we see an opposing trend of the different research fields keeping to themselves, right? So therefore interacting less. Then we also have to negatively acknowledge that the pace of political discourse is quite lacking behind the technological progress we see, and also that customers in society are actually quite uneducated on what AI really is and what kind of impact it carries. This is why we have this talk today, okay? Now, next in the definition, we say that RRAI should foster this mutually responsive behavior with a view to the ethical acceptability, sustainability, and social desirability. And again, we see the Asilomar principles, we see more and more economic impact studies, and we see a rising legal discourse around the use of AI by companies. So that's positive. Negative is that the field is still strongly dominated by technical research aiming at purely efficiency gains, not really posing ethical and societal questions. And if studies and researchers and politicians do, they mainly focus on short-term consequences and neglect the long-term effects a little bit, okay? Lastly, we have this distinction between the innovation process and marketable products. And here we can see that the opportunities and risks of artificial narrow intelligence, so narrow machine learning applications, are actually quite well understood. However, what we have to acknowledge is that the role of AI in innovation processes and innovation systems is quite heavily underexplored, and that consequences of artificial general intelligence are, for example, not much in the focus of research and policy discourses. Okay, so again, I leave you to judge whether the innovation system around AI is actually going in a responsible direction or moving away from it. But these are just some arguments I wanted to make at the end of this talk. And this basically concludes everything I wanted to tell you about AI and responsible research and innovation. I hope it was inspiring to you, and you are now starting to, create your own thoughts and think about all of these issues we've discussed in this talk. I want to give you one more recommendation. If you need a crash course that is easy to read, what AI is, where it came from, how it developed, what kind of consequences it carries, and if you want to maybe get friends or family into this topic, there is a great comic book that I can recommend, which is called We Need to Talk AI. It's freely available. You can check it out at weneedtotalk.ai is the URL. Okay, so please check that out if you're interested. And this basically concludes this guest lecture in the course Recent Developments in Innovation in Advanced Innovation Economics, talking about AI and responsible research and innovation. It was a lot of fun for me. These are my references. You can also find all of the references on my homepage, johannesdahlke.com, where I will set up some posts accompanying these videos. And I want to thank all of you for your interest and listening to me through these three very long videos talking about AI in society and AI in the innovation process. I want to thank you, Michael, for inviting me to hold this guest lecture. It was really educating for me to prepare all of these contents. And if you want to stay in touch, please follow my work at johannesdahlke.com. And lastly, as a very last thing here, I want to apologize to Andrew, which I misrepresented maybe a little bit in the first part of this lecture series when I cited one of his remarks where he was saying, okay, don't worry about evil AI. It's the same like worrying on overpopulation, about overpopulation on the planet Mars. Of course, this is not the sole opinion of Mr. Andrew, who also has said this quote that I would like to share with you and leave you with, ending this talk here. And he said, "We have seen AI providing conversation and comfort to the lonely. We have also seen AI engaging in racial discrimination. As leaders, it is incumbent on all of us to make sure we are building a world in which every individual has an opportunity to thrive." Thank you for your interest, and see you next time.